Hello, once more again, this is your teacher, Mr. Anolinkia, who is going to take you in logarithms. You're welcome. Now, what is logarithm? Suppose you have this number here, 9, which is equal to 3 squared. From the knowledge of laws of exponents, 3 is the base. Now, from here, we can see that to obtain 9, you have to raise 3 to power 2, put to exponent 2. Now, these two here is the logarithm of 9 to base 3, written as expressed as 2 equals log 9 to base 3. Log is the short form of logarithm. Similarly, 0.001 can be written as 10 exponent minus 3. It implies that minus 3 is equal to the log of 0.001 to base 10. Also 1 of 125 can be written as 5 exponent negative 3. It means negative 3 is equal to the logarithm of 1 over 125 to base 5. So from these 3 judgments which we see here, we can now generalize. So in general, if y is equal to a exponent x, then x will be equal to the logarithm of y to base a. This equation here is an equation in exponential form. This one here is an equation in logarithmic form. So you can now just write a short definition of logarithm. Thus, logarithm of a number is the number of times another number is raised to obtain the original number. In short, when you're talking of logarithm, you're actually talking of the base, the exponent to which the base must be raised to obtain a certain number. That's why the laws of exponents are very important when you are discussing about logarithm. After this definition of logarithm, we can go ahead into these two very important expressions in logarithms. Log A, exponent A, and log AX base A. So log A base A and log A exponent X base A. Our intention is to find their values because they are very important when we'll be talking about the laws of logarithms. So let logarithm of A to base A be equal to t. Now, we can change this logarithmic equation into exponential equation as this A here, A is equal to A exponent t. This A here is equal to A exponent t. But A is equal to A exponent 1. Thus, A exponent 1 is equal to A exponent t. Meaning that t is equal to 1 by comparing exponents. By comparing exponents from the fact that in this exponential equation here, the base is common. The base is common. Log A exponent A is equal to 1. This is one important behavior of logarithms. Number 2, log AX base A. Let log AX base A be equal to M. Again, we can say that AX is equal to A exponent M by changing this logarithmic equation into exponential equation. And X will be equal to M by simply comparing exponents. Comparing exponents. Note that the base is the same, A. Therefore, since M is equal to X and log AX base A is equal to M, so we can replace M by X, or we can substitute M for X, meaning that log AX exponent A is equal to X. This is the second important behavior I wanted you to have noted. After having this foundation, we can now look into laws of exponents. Now, laws of logarithms. Laws of logarithms take us into 4 categories: category of product, category of quotient, category of power, and category of root. Or in short, logarithm of product. Law of product in logarithms, or logarithm of products. Now, suppose x is equal to Suppose x is equal to a exponent b and y is equal to a exponent q. This implies that these two equations can be expressed as p equals log x base a and q equals log y base a. Then, since we are talking of product, let us now find the logarithm of x times y to base a, meaning that we are looking for the logarithm of the product xy, which is going to be equal to the logarithm. Instead of x, we can write ap times aq. But this can simplify into logarithm a p plus q, p plus q. Here, a exponent p times a exponent q is a p plus q. We just add the exponents. But again, this one is equal to p plus q from what we just learned, that the logarithm of ax to base a is x. So our x here is p plus q. Now, from the above statement, what is p plus q? P is log ax and q is log y to base a. Therefore, this is the same way. Instead of p, we replace it by log x, and instead of q, we replace it with log y. Henceforth, logarithm of xy to base a is just equal to the logarithm of x plus logarithm of y. This is the so-called logarithm of a product. Next is logarithm of quotient. Quotient, of course, takes us to division of quantities. When you divide them, you realize quotient. And we are going to look into the logarithm of x divided by y. Now, from the step number 1 above, we saw what was x. X was ap and y was aq. So we can replace x and y by these two quantities, a exponent p and a exponent q. So this is the same as saying log a, instead of x, you write a exponent p divided by a exponent q. A exponent q, which is the same as log, but a p divided by q, a power p divided by a power q is the same as a p minus q. This is again true from laws of exponents. Therefore, and this is the same as p minus q from this law here, log a x is equal to x. Therefore, instead of p, we can write it as log x minus log y. Henceforth, log a x over y is simply equal to log x minus log y. This is the logarithm of a quotient. Number 3, logarithm of a power. Here we are going to look into the logarithm of x exponent n base a. But from the earlier steps, we had seen that x was just a exponent b, then raised to n, which is equal to log a b n. And this is the same as Pn, but P is equal to what? P is equal to log A log x base n. Sorry, P is equal to log x base a from the steps number 1, where we defined P, Q, X, and Y. And this can be written as n log x base a. Therefore, log x exponent n base a is simply equal to n log x base a. This is our logarithm of a power. The logarithm of a root. I think what is important here is to remember that the logarithm of a root or radical, is actually it is just a certain number raised to a fraction of an index or fraction of an exponent. Therefore, we are looking into logarithm of nth root of x to base a. So our first assignment here is to express nth root of x in exponential form, which gives you the logarithm x1 over n base a. Remember, nth root of x is just x exponent 1 over n. So that's what I've done here. And this one, if you go to logarithm of a power, here the exponent was n. Here the exponent is 1 over n. So this is just equivalent to 1 over n log x base a, remembering that this is just an exponent in fraction and this one is just an exponent as a whole number. In so doing, then it means the logarithm of nth root of x to base a is just equal to 1 over n log x to base a. So that takes us to the end of laws of logarithms, and determine the value of x if logarithm of x to base 2 is equal to 1 minus logarithm of 3 to base 2. Solution logarithm of x equals 1 minus logarithm of 3 to base 2. Our steps here is to combine logarithm or collect all the terms with logarithm together by adding logarithm 3 base 2 to both sides of the equation to get the logarithm of x base 2 plus logarithm of x of 3 base 2. This is the same as 1 minus logarithm 3 plus logarithm 3. This gives you logarithm x plus logarithm third base 2 equals 1. Then we can combine this one as logarithm of base 2 x times 3, which is equal to 1. This is from logarithm of product. This gives you logarithm x times 3 is 3x equals to 1. And then we can even change this one, logarithm 3x, to be equal to logarithm 2 base 2. Remember, 1 can be written as logarithm 2 base 2. Now, if you look at this equation here, we have log 3x and log 2. Both of them are under base of 2. Therefore, this equation becomes true if and only if 3x is equal to 2. 3x is equal to 2, meaning that x should be equal to 2 over 3. X should be equal to 2 over 3. That is our solution. Find x. If log x base a is equal to a half log 4 base a plus 1/3 log 27 base a. The solution goes as follows. Log x equals a half log 4 plus 1/3 log 27. Now, half log 4 can be written as log 4 exponential half using the law of power. And this one, 1/3 log 27, can be written as log 27 exponent 1/3 from logarithm of power or root. But 4 can be written as 2 exponent 2 power half, and 27 can be written as 3 power 3 exponent 1/3. On simplification of 2 exponent 2 exponent a half and 3 exponent 3 exponent 1/3, this boils down to a2 plus log base a3. This is basically from laws of exponents. There is that law which says ax exponent y is just equal to a exponent xy. So you multiply the exponents. Even here we've multiplied the exponents. 2 times a half is 1. 3 times 1/3 is 1. And now this, we can combine them using the law of product as 2 times 3 from law of product, or from logarithm of product of logarithms. So this gives you log 6, meaning that log x base a is equal to log 6 base a. So long as the base is the same, this equation will only be true if and only if x is equal to 6. So that is our solution. X is equal to 6. Question number 3. Simplify logarithm of root 10 times logarithm of 100 divided by logarithm of 10. Now it is important to note that if logarithm is written without a base, it implies that the base should be taken as base 10 or common logarithm. Therefore, this equation can be written as log root 10 base 10 over log 10 base 10 times log 100 base 10. And this one goes into logarithm 10 exponent a half using the law of logarithm of roots times log 100 over log 10 base 10. This is the same as a half log 10 over log 10 base 10 times log 100 can be written as 10 exponent 2. 100 can be written as 10 exponent 2. Now, this log 10 base 10 and log 10 base 10 can cancel out, and this goes into a half times this one here, log 10 squared base 10 is just equal to 2. So times 2. And 2 and 2 will cancel to get 1. Therefore, log 10 root 10, or rather log log root 10 over log 10 times log 100 equals 1. That is the solution for question number 3. Question number 4 can come here. You are told, given log 25 base x is equal to 2 evaluate x. Find the value of x. Solution. Log 25 base x is equal to 2. X is the base. We have to change this equation from logarithmic form into exponential form as follows. 25 equals x squared. And then we can rewrite 25 as 5 exponent 2 is equal to x squared. And since the exponents are equal, that is, they are both equal to 2, we can compare the bases. Compare the bases. The bases in this equation here. In so doing, you'll find that 5 is equal to x. Therefore, x is equal to 5. Yeah, thank you for now. We've covered our laws of logarithms. You are welcome again. Thanks.